Hello, here is the last of the Year 12 assessment revision videos. So these are the solutions to the logs and exponential section. So let's head to the sheet. So with our logs, we are essentially using 3 or 4 different things. So it's all about being able to switch from exponential form, which we're very used to saying, okay, a to the x equals b, you know all about powers. But that is equivalent to stating that log to the base a of b is equal to x. So, of course, you know that the log function takes, well, it's the inverse of exponential functions. So what we have here, a to the power of x, a is the base there, and then x is the power. So that is the result of your log, and then what appears there appears within that log. So you need to be really comfortable in moving between those. And of course, if you're ever confused with that statement there, just think, okay, right, 2 cubed is equal to 8. So that is equivalent to saying that log to the base 2 of 8 is 3. Okay, because sometimes that statement in the box can look a bit abstract and you're, okay, what does that mean? Just write it down with some easy numbers and all hopefully will become clear. So as well as that, we have got the log rules. The log rules essentially come from the index rules. Log of a plus log of b, we can write as log of ab. We know that log of a minus log of b is equal to log of a over b. And then we also know that n log a, or I think it's more in this way around, isn't it? So log of a to the power of n is equal to n log a. And every single one of those have to be in the same base. So note, I haven't actually written what the base is. So quite often you might see kind of a little x happening throughout there. However, we'll get rid of those because it's just understood that they're all the same base, and it just really makes things look a little bit messy. The way that it's written there anyway kind of looks as if we have got a log of base 10. Sorry, I'm just pausing because I haven't Bluetooth my headphones up, so I hope that the iPad mic is picking everything up okay. I'm sure it will be. Sound might not be as good though, I'm sorry. Together with that, we of course have the fact that log to the base 10 of 10, for example, is equal to 1. So if you have a log together with its kind of base, so log to the base 10 of 10, that of course is 10 to the 1, so that's equal to 1. Okay, so we need to keep all those in the background when we're working out these questions here. So solving. So we need to work out what x is. Just think about how you would rearrange any ordinary equation and divide both sides by 2. You could, of course, use this rule here, but there's no need to. It just makes things more complicated. You'll get the same answer, but just divide both sides by 2. Now, if you use this rule, so think clearly what each of these things are. So 2, so this 2 here is the base. That 2 there is the power, and that is equal to x. So x equal to 4, and let's just have a check. So log to the base 2 of 4 is equal to 2. Yeah, well, of course it is, because 2 squared is equal to 4. Yeah, that all ties up. And of course, you could just also type that into your calculator, just clarify. that does get you the same answer. Okay, so hopefully that one not too tricky. Moving on, essentially this is just the same, isn't it? It's the same kind of structure. You've got, we don't have to do the dividing by 2 business, so there we had a number in front. Here we don't, we've just got a single log equaling an answer. Don't worry at all about the fact that you've got a power of x appearing there, sorry, not power of x, a base of x appearing there together with an x in there. Just use the form to rewrite it, and we would get x is the base, power is 2. The answer is 5x minus 6, and you can see that what we've got there is just a quadratic. An alternative way, I didn't mention it on the previous one, but some of you may just prefer a more automatic method of raising each side to the power x, not raising to the power of x, using a power of x. So let's get rid of that word raising. I'll show you what I mean. So if I say, okay, x to the power of the left-hand side is equal to x to the power of the right-hand side. So by doing that, those 2 terms there, of course, cancel, because you've got x to the power of something and then log to that same base. They are inverse functions. So that just leaves you with 5x minus 6 equals x squared. So it's exactly the same as what I could have wrote down before. So let's go back to this step here. So x is the base, the power is 2. I'll write that. So then take everything onto one side. Solving that, I've x equals 3 and x equals 2. So all looks good. What we should just check, however, because you know that the log function only exists for positive values, and even though 3 and 2 themselves are both positive, it's worth checking that when we put them back into there, the part in the bracket remains positive. So 5x minus 6 when x is 3 is going to be 5 times 3 minus 6. Yeah, that's positive. That's 9. So I know that log of 5x minus 6 is defined. And then if we check out what 5x minus 6 is for the smaller one when x is 2, we're still okay, because 5 2's minus 6 is 4. So log of 5x minus 6 exists there. If x was 1, so if we'd have had an answer of 1, popping that in there, we would have got log of 5 times 1 minus 6, and that would get log of negative 1, and log of negative 1 doesn't work, so we wouldn't have, oops, there we go, so we wouldn't have any solutions there. So it's not worth, or it's not enough just to get you 2 answers from here. We do just need to make sure that they work for both those values. Okay, now this one here. This is tricky because we've got 3 terms. We've got 1, 2, 3 terms there. When we had in the previous question here a single log together with a number, we could get rid of the log by using this statement here. In the very first question, which looked much simpler, we still couldn't deal with it at the very first line, could we? What we had to do, we had to divide both sides by 2 so that we got a single log equaling a number. So we can only deal with this question. Come on, let's move back up, please. We can only deal with this question if we've got a single log equaling a number, and in particular equaling that number 2 there. So what we need to do first is to rearrange to get all the log terms on the same side. So in particular, what I'm going to do, I'm going to put them all on the left hand side. So log to the base 4 of 3x plus log to the base 4 of 2 is equal to 2. Now that I've done that, we can use some log rules, because we have got 2 individual log to the base 4 and we've got a plus there. So we can use this. I can write those as single log by using my multiplication addition rule. So I'm going to have log to the base 4 of 3x multiplied by 2. And that is equal to 2. So note, I haven't taken logs of both sides. It's not that. What I'm doing is I'm just using the log rules to manipulate what we've already got, writing it in an equivalent expression. Simplifying that left-hand side, that's telling me that log to the base 4 of 6x is equal to 2. And now that I've done that, I can rewrite it as a exponential equation. So you can either think of it as having a base of 4 raised to each of those things. So the 4 log to the base 4 cancel out, just leaving you with 6x equaling 4 squared, which is 16. Or alternatively, just rewrite it thinking, okay, I have got a base of 4, I have got a power of 2, and then that is equal to, that is 6x. And you can see that I've got exactly the same. In each case, we just end up with 6x equals 16. And x is 16 over 6, 8/3. So which of these you prefer? I think for me, it depends on, context of the question as to whether I do that or do that. Probably for these ones with simpler ones, I would probably do that one there, but you can see, it doesn't matter. Both of them certainly valid ways. Okay, so this one, the idea actually is what we've just done, and it's even giving us a hint. So you can see if you look at part B, it's asking you to solve that equation. But the deal is that we can't solve the equation until we've written it as a single logarithm. So you can see that part 1 of this equation, or part 1 of this question, actually asks you to write it as a single logarithm. So giving you really quite a nice hint there. So if we look at this expression, we have got 2 terms. And because of that negative, you're thinking, right, okay, I'm going to be using my subtraction division log rule. However, you cannot do that yet because of this 2. So first you need to remove that 2, but we can do that fairly straightforwardly by using our power rule. So I can take that 2 and move it up there and have it as a squared. But you need to very much stick to your 2 different stages. Now I've done that, I've got one thing, the second thing, they're both base log 3. So I can say, right, that is log to the base 3 of x squared over x plus 4. And that is my single logarithm. Okay, what is inside the logarithm? We know it's a bit big and clumsy, but we have taken those 2 separate terms there, moved the 2, and we've written it as a single log. So now, hence solve. So what we can do now is go on to, instead of solving that given equation, we are instead going to solve this, which of course is just the equivalent expression, isn't it? So I've got x squared over x plus 4 equaling 2. So just say again, instead of all of that equaling 2, we showed that that was equivalent to that. So I've got that equaling 2. And now I need to rewrite that as an exponential equation. So this is my base 3. This is the power, and it's equal to this answer. Another quadratic equation. I'm going to go over here. I'm going to try and fit it in this gap. So I've got 9 equaling, actually let's do those 2 stages at the same time. So I'm going to have 3 squared multiplied by the x plus 4 equaling x squared. And so I get x squared minus 9x minus 36 is 0. X 12 and 3. So either x equal to 12 or x equal to negative 3. Now this, we mentioned this earlier, you need to go and check, and I can very quickly see a problem. These 2 answers are both answers for this quadratic. However, if you were then to go and look at the original equation, our original equation is 2 log to the base 3 of x minus log to the base 3 of x plus 4. If you put negative 3 in there, that doesn't work. And 2 log to the base 3 of negative, that is undefined. So logs are not defined. Let's try writing that again, shall we? For any negative value of x. Undefined. So actually that second one is not a solution. So there is only one solution. And that occurs when x is equal to 12. And I haven't actually kind of said this, but of course, put 12 in there, it's fine. Put 12 in there, yeah, that's fine. Both of those turn a positive. Both of those work. So just check at the end. If you had have left your answer like this in an exam, you wouldn't get all your marks for the question. Okay, so this one here, giving your answer in exact form. Here we've got a particular base. Our base is log to the base e. We've got those natural logs there. So this is very much like the question from a couple of questions ago. I can't rewrite it in exponential form yet. We cannot do this. That, of course, is not allowed, okay, because of that plus there. So you would have to take exponentials of the whole of the side of the equation. So I could write e to the ln x plus 1, but then I would have to write e to the ln x minus 2 plus 1 like that. And then it means that power is a little bit awkward. You could, of course, work it out. And in fact, I'll keep going with this. I'll show you kind of two different ways. So let's get rid of that. So we could state that e to the ln x plus 1 is equal to e to the ln x minus 2 plus 1. Now, e to the ln x, that of course inverse functions, so that just gives me a nice little x plus 1 on the left hand side, but I can't do that on the right hand side. I've got an e to the ln x there, but I've got this awkward add 1 just tagging along. But you can use your rules of indices. You can say that is e to the ln x minus 2 multiplied by e to the 1. Okay, so think rules of indices, yeah, same base, adding those, that works. And now x plus 1 is equal to, we do indeed have now e to the ln directly next to each other, so I can write that as x minus 2 multiplied by e to the 1, it's just e is just a number in the same way that pi is. So then x plus 1 is equal to e times by x minus 2e. I want to make x a subject, so 1 plus 2e is equal to ex minus x. Take x out as a factor, and then finally divide 1 plus 2e over e minus 1. Or another way of doing it, which is kind of the way that the previous questions were edging you towards. I can't undo that. I can't write it as an exponentials because I've got logs on both sides of the equation. So I'm going to rewrite that as ln x plus 1 minus ln x minus 2 equals 1. I'm now going to use my log rules. Because I've got a subtraction there, it means that I can write that as log of the first thing divided by log of the second thing. Now that I've done that, I can rewrite in exponential form. So because I've got ln, I know I'm looking at base e. So imagine that little e going in there, e to the power of 1 is equal to that answer, x plus 1 over x minus 2. And now we end up at exactly the same point. Well, almost. I'm one step away, aren't I? If I multiply by that denominator, I'll have e multiplied by x minus 2 is equal to x plus 1. So we are at almost at this stage. No, we're a slightly different way around, aren't we, to that? Oh, we're up here, aren't we? We're at that state there. So ex minus 2e equals x plus 1. Get the x's on the left. Ex minus x is equal to 1 plus 2e. Factorise out the x's as before. X equals 1 plus 2e over e minus 1. Okay, so there looks to be a few more lines, doesn't there, on the right? There's that kind of red line in the middle, maybe taking up a bit of space, but doesn't matter which way, I mean, depending on which class you're in, you've maybe done more of one thing than the other. Okay, all right, so I think they're all the exponential ones, apart from this one. Is that the same question? It is the same question. Okay, so we're obviously not going to do that one again. I need to remember to delete that. So I think just to finish with, we've got a couple of questions the other way around. So we've been given the exponential equation and we need to solve it using logs. So here, take logs of both sides. It says give your answer correct to 3 significant figures. So we could do one of two things. Or one of actually a number of things. You could take log to the base 5. So taking log to the base 5 here would be good, because the log to the base 5 would then cancel with your power of 5, with your base of 5 here. And that just leaves you with x plus 1 equaling log to the base 5 of 14, which means that x is log to the base 5 of 14 minus 1. Now, up until very recently, we wouldn't have been able to do that because we didn't have a log to any base on our calculator. But I know that my class in particular like doing this, taking just whichever convenient base is, working that out, we get 0.6. It's 397, so that would be 0.640. So the alternative is, rather than taking logs to base 5, you can take logs to any base. So you can take log to the base 10. I think quite a few people like taking natural logs. So this could be log to any base, but let's do it log to the base e. Now we would use the log power rule. Take that from there and pop it at the start as a multiplier. And then think about how we would rearrange that to get to x. Okay, well, I will divide both sides by log to the base 5 and then finally subtract 1. So that is the exact answer. But if you were to work out that as a decimal, when I'm typing it into my calculator, I don't know why, we all know it's going to be the same. Minus 1. Oh, yes, there we go. So x is equal to 0.640. Okay, so either of those perfectly valid methods, and doesn't have to even be log to the base natural log. You could do log to the base 10, log to the base 17, whichever. Number 29. Again here, let's take log to the base 7 on the left-hand side. So I'm taking logs at both sides. Log to the base 7, 7 to the power of 2x minus 5 equals log to the base 7 of 2. The log to the base 7 and the 7 cancel, leaving me with 2x minus 5 on the left, equaling log to the base 7 of 2. And then rearrange. So x is log to the base 7 of 2 plus 5 all over 2. Correct 2 decimal places. Log to the base 7 of 2 at 5 and then divided by 2. That's 2.68. Or I'll do log to the base 10 this time. No, I'll stick with log to the base e. As I said, I think it's a preferred method for lots of you. Take logs of both sides, use that power rule to have that as a multiplier. And then, I mean, you could expand the brackets, couldn't you, and divide. I don't know whether that would be the instinct of many of you. Let's expand the brackets this time. I didn't on the previous one. So 2x ln 7 would be equal to ln 2 plus 5 ln 7. So then x is equal to ln2 plus 5 ln7 over 2 ln7. And if you work that out, we're going to get to the 2.68 again. If, by the way, it said write it in exact form, we could use our rules to simplify this, because I've got ln2 plus ln, oh, it's not very nice, is it? 7 to the power of 5 over ln7 squared. Okay, so 7 to the power of 5 obviously is quite a big number, but we could have 7 to the power of 5 times by 2 all over log of 7 squared. And the last one. No, that's not duplicated. Is it this one here? Yeah. So here we have been told to take natural logs. I should say that we always get the same answer, but for exam questions, you would have different versions on a mark scheme depending on which log base you took. Here, it is telling me to take natural logs of both sides. So let's have that as ln all to the power of 2x plus 1 equals ln of 3 to the 6 minus x. So I've got 2x plus 1, lots of ln 4 is equal to 6 minus x, lots of ln 3. Okay, so I think here, expand the brackets. We've obviously got to collect the x's together. There are x's appearing on both sides. So 2x ln 4 plus ln 4 is equal to 6 ln 3 minus x ln 3. I'm going to collect the x terms together on the left-hand side. That will make them both positive. And then 6 ln 3 minus ln 4. Okay, now we are going to have quite a big number, I think, on that right-hand side, because I've got 3 to the power of 6 coming up. But let's not get distracted. Let's do the left-hand side first. So I've taken out x as a factor. So now I've got ln of 3 to the power of 6 minus ln of 4. Here on the left-hand side, I've got ln 4 squared plus ln 3. Now 3 to the power of 6, I think 729, yes. So that's ln of 729 minus ln 4. I've got x times by ln 16 plus ln 3. And now on the right-hand side, I can write that as the natural log of 729 over 4. And of course, that doesn't simplify at all. So leave it as 729 over 4. The left-hand side, I will have ln of 16 times by 3, ln of 48. And so finally, I can do division. So this isn't a very nice number. I guess you might be a little bit put off by it if this was an exam question. ln 729 over 4, all over ln of 48. And of course, can't do anything now because you have got a division of 2 separate logs. You cannot rewrite that using the power rule. If you've got a subtraction of 2 separate logs, as here, you can write that as log of 2 things divided, but we can't do the other way around. Okay, so thank you. I will upload these answers so you can look at the paper copy without having to listen to it all, although if you've got this far, presumably you did already. Stop recording, please.